All right, in this video, I want to discuss how to calculate a confidence interval for a population proportion. And right now I'm looking at a data set on the bunch of cars. So I have 10 cars here. This is a random sample of car data. And in particular, I'm focused right now on their price. Okay, and I know I said I want to calculate a confidence interval for a proportion. So hang in there with me for a minute, and let's talk about how we're going to get to a proportion. So first thing I want to do is calculate the sample average of these cars. So the sample average, or X bar, right, equals average, open parentheses, highlight your data, okay, close parentheses. So my cars, their average price is $21,054. All right, so I want to go ahead and define P, right? This is what I'm interested in right now. I'm interested in knowing the proportion of car prices less than $21,054. Okay, so that's my main interest right now. Okay, so let's go ahead and if that's the proportion of cars, this P would be the population proportion. Okay, population proportion of cars that are less than $21,054. Right, and of course we don't observe a population, right? But we do have 10 observations. So let us find P hat, which is our sample proportion of cars less than $21,054. So to do this, I could just count how many cars are less than this, $21,000, and then divide that by the sample size. Or I could actually use Excel to count it for me. So count if, open parentheses, highlight your data. Okay, that's the range. The criteria, okay, so hang in there because this is the way you write the criteria is a little strange, but you can do this. So do a quote, a less than sign, and then an end quote. Okay, so we want the less than. And then you use an and sign. So that's shift number 7. Okay. And then click on the whatever you're trying to figure out your less than. So I'm less than 21. So click on that cell. Okay. Close parentheses and then press enter. Okay. So that's the number of observations that are less than $21,054. So to find the proportion, I divide that by the sample size, which is 10. So I divide that by 10, press enter. So 50% of my observations are less than $21,054. Okay, and that is, of course, that is a sample statistic. Okay, so that P hat is from the sample. Right, and we want to use that to tell us something about P, which is from the population. Right, and here the population would be, if I were to go out and collect all the different types of cars that are currently for sale, and I were to find the proportion of them that are less than $21,054, that proportion would be the population proportion of all the cars, right? And the sample portion is just of my 10 cars. So the chances that the population proportion is exactly equal to the sample proportion is basically slim to none. So what we do when we construct a confidence interval is we go certain buffer zone around the sample, right? And then we say, okay, we are a certain level of confidence, so say 95% confident, that P is somewhere inside of this confidence interval. The population proportion is somewhere in this interval. All right? So that's the idea behind confidence intervals. Okay, so how do we construct that buffer zone? We basically take our estimate and we subtract off some margin of error, or E, and we add on some margin of error, or E. So P hat minus E, and then P hat plus E. All right, and that's how we construct our confidence interval. All right, so this is what we need to figure out. We need to figure out what is E, and then we can construct this confidence interval. We already know what P hat is. All right. So to figure out what that margin of error E is, the first thing I'm going to need to know is the standard deviation of that proportion. Okay. So actually, first thing I want to know is what's Q hat, which Q hat is always 1 minus P. So whatever P is, 1 minus it. So 1 minus whatever P hat is, press enter. Okay, so the standard deviation for this proportion, right? Not the standard deviation of the sample, right? That's not what I'm finding now. I'm finding the standard deviation of P hat, or it's really of the binomial distribution, right? So the binomial standard deviation equals SQRT, open parentheses, so that's a square root function, P hat times Q hat, close parentheses. Okay, press enter. All right, I know it's all coming out to 0.5 every one, but it's not going to be like that always, right? So like right now, if I were to change this, say to 0.7, you see everything changes, right? So let me undo that. Okay. All right, that just happens to be for this particular example. It's all 0.5. All right, so now I'm ready to calculate E, the margin of error. Oh, well, actually, before I do that, I want to talk about the confidence level. The confidence level. So my confidence level right now, let's use 0.95, 95% confidence. Then alpha is always 1 minus your confidence level. Alpha is your type 1 error. It's your acceptable error, right? So we're 95% confident that the population proportion is somewhere in this interval. And then we have basically an acceptable 5% mistake rate, okay? Or error rate. Okay. So E equals confidence. Now, confidence intervals for proportions are always Confidence.Norm. We don't use Confidence.T for proportions. Okay? Alpha, just click on that cell. The standard deviation we found, okay? It was that square root of P hat times Q hat. The size is the sample size, which is 10. Okay, close parentheses and press enter. All right, so now I have everything I need to calculate that confidence interval. So let me start with the lower CI equals P hat minus this margin of error. Okay, upper CI equals P hat plus this margin of error. All right. A lot of times confidence intervals for proportions are given as percentages. So if I go, let me close that. If I go up top to home and I click on these cells and I press the percentage button and then say I want more decimals, I can press over. Okay, give me a little more decimals. And there we go. I see my confidence interval. All right, so I am 95% confident that the proportion of car prices, the population proportion of car prices less than $21,054 is somewhere between 19.01% and 80.99%. Okay. All right. And if I were to decrease that confidence, say to 0.75, my confidence interval would become more narrow, right? It's between 31.81% and 68.19%, right? So as I become less and less confident, the confidence interval goes closer and closer to P, which makes sense because I'm not very confident that the population proportion is very close to my sample proportion. Right? As I get more confident, say confidence level changes to 0.99, I see that confidence interval getting even wider. Wider confidence. I'm very confident that I'm further, that when I have a wider interval around P. Okay, now you may have noticed that I use Confidence.Norm, and there is another way that you could have calculated this margin of error using the formula for margin of error, which is E equals the Z critical times the square root of P hat times Q hat over the square over N. Okay, you could have used this formula, and you would have gotten the same thing. So let me change this back to 0.95. And let's talk about that. So if I wanted to use this formula, first thing I would need to know is what is that Z critical, right? Equals norm dot S. S is for the standard normal or the Z normal dot inverse, open parentheses, and the only thing it wants to know is the probability. Now, since I have two tails, I need to give it alpha, but then I need to divide it by 2. Right? So the normal distribution in Excel, it doesn't have that 2-tail inverse function like the T does. So because it doesn't have that, you have to manually divide it by 2 to say you got 2 tails. Close parentheses and press enter. Okay, now they'll give you the negative value when you do that. So one way that you can get the positive value is just do 1 minus that. And it's the positive. Now, see, they're exactly the same. It was the same number with or without that 1 minus. It's just positive versus negative. Now, your Z critical, but by default, your margin of error, it's always positive. So go ahead and use that positive version. Okay, so 1 minus that alpha divided by 2. Okay, or if you got the negative Z, just make it positive by deleting the negative sign. Okay. Okay. So then, if I want to calculate E, I would write equals that Z critical value times SQRT, open parentheses, that's the square root, of P hat times Q hat divided by N, which is your sample size. Close parentheses and press enter. Okay, so what you're seeing there, so we have square root of P hat times Q hat divided by N. Here, and then you have to close the parentheses for the square root symbol. Okay? Enter. Now, this margin of error is exactly the same as that margin of error. Okay, so you can use this formula over here, or you can use the shortcut, which is basically this Confidence.Norm. Either way, you'll get the same answer.